a picture of David, but it'll do. We're not streaming to anyone. So what did we work on yesterday? URL shortening. What parts of Tiny App were you doing? Everyone gets cookies? Yeah? What are cookies? Doesn't remember anything. So what? Yeah. So cookies are solving that. What do we? What is the problem there? Like, it's not remembering. What do we refer that? Stateless. So HTTP is stateless, which means that it just doesn't remember anything. We make a request to the server. We can tell it, "Hey server, I'm Sam. I'm doing this kind of stuff," and it'll be fine for that request. It will have all that data. Then we make a subsequent request, and it's completely forgotten who I am. It's like, has anyone seen 50 First Dates? Is it Todd or Tom? One of the guys is like, "Hey Tom," or like, "Hi, my name's Tom." And 3 seconds later, he's like, "Oh, Tom." Basically, web servers are like that. They're good at other things, but not at persisting data or remembering things. They are stateless. Persisting. So how do we get around this? We use these things called cookies. Why are they called cookies? I actually don't know. It's a bit of fun, you know? Is it what? Magic cookies? Magic cookies. Cool. Okay, yeah, so it's solving this issue. How do cookies work? So has anyone heard of this thing called silicon milk roundabout? Or looking at the Brits in the room. You have. Anyone else heard of silicon milk roundabout? What's that? Silicon milk roundabout. Yes. It's a thing in London, the real London, not the Canadian London. And I've gotten screwed over. I was on Apple, support with Apple once, saying that I was in London, and they thought I was in like Canadian London because I called Apple for some reason. It was just the number in my phone, and they were trying to route me to the closest Apple store, and it was far away. Anyway, Silicon Valley is in San Francisco. In London, the kind of tech sector there is called Silicon Roundabout. I had fun with that. Silicon Milk Roundabout is a job fair, the biggest in London, where you can go as a developer and try and get a job. I went to Silicon Milk Roundabout about 3 or 4 years ago, and when I showed up, I had to give them my ID so that I could verify that I was Sam. And when I did that, they then gave me this name badge that verified my identity. It had, I think, a little barcode on it, and it could get me into Silicon Milk Roundabout, and it showed who I was. Once they'd given me that, I could also add these little fun stickers that showed what kind of skills I had. So there was a JavaScript sticker, an iOS sticker. I could put that on. And then every booth I went to, every company that was there, knew what my name was, who I was, that I was supposed to be there, but they also knew this extra information, like, he knows JavaScript, and he's an iOS developer, so I can ask him questions about that. And this was really handy, because instead of having to go to each booth and explain who I was and what skills I had, they could immediately see that. And instead of having to show my ID and verify who I was every time I entered the job fair, I just had this name tag, this kind of verification that I was supposed to be there, I was who I said I was. And the way that worked is that Silicon Milk Roundabout provided me with it. They gave me this name tag. It was given to me by them. I didn't just make it myself. And as long as I held on to that, as long as I had that when I was there, I was verifying who I was and providing them with extra information about myself. So when we're making requests to a server, when a browser makes a request to a server, how does the server know anything about the browser? How does it know the user that's using it? How does it know any of that information? Cookies? Is there any other way? What's a user agent? So user agent, yep, cool. There's user agent. Can everyone see that? Can everyone see that user agent at the bottom? Yeah, it's information supposedly about my browser. I'm using Chrome. It's saying I'm using 5.0. That's the box. I am on a Mac. It's also saying Apple WebKit. That's Safari, not Chrome. So yeah, there's this user agent information, but it's not always accurate. And as a user, as a developer, I can go in and just change that. I can make a request saying any user. I'm Don Burks. Fine. So how else can we provide this information to the server? How can we let the server know who we are every request? Well, like you said, cookies. We can do it with cookies, and really cookies are the best way of doing this. And what a cookie is kind of like a name tag that I got from this job fair. I make a request to the server, the browser makes a request to the server, and the server will generate this name tag, this bit of information that the browser has to hold on to, called a cookie. And as long as the browser holds on to this information and shows this information every time it makes a network, the server will know who the user is, the information about the browser that is needed, and can provide custom information to that browser, provide a custom user experience. Because without that, a web server would have to provide the same data for absolutely everything. Imagine going to Facebook, friends post, and every provide you with a custom user experience. So yeah, so we use cookies, and they're generated by the server, and then the browser holds them. As long as the browser has them, we can authenticate them, like this little name tag that the browser now has. So let's take a look at how to use cookies. So I'm going to create a website. And how do I create a new expression? Create an index.js. Press start. Whoops. It's got the new MacBook Pros with. I accidentally such a right word problem. Like, I've got the touch bar and I accidentally touched the. Okay, let's see. Next, yes, create an Express app. Express. Everyone using constant let instead of var now? Sometimes. Allow the user root. Request response or response request? I have typed that enough. An arrow function. Now what should we do when it comes to probably show them some HTML? What are we using right now in TinyApp to show HTML? Template engine. EJS. Good. npm in. How do we include EJS? Set viewing. Hold on, I appreciate, but there it is. I carry around code sniff times. Okay, so we set the view engine to EJS, and maybe we'll render. We'll just create an index. Yes, and app. Okay. Let's create directory. I'm going to do this. Touch. I'm going to show them this index.html. Right, it's got to be index.js. Thank you, pair programming. I'm just going to jazz hands for now. See if I've got all this correctly. Index. Then we're going to be dealing with sessions and cookies and passwords and stuff, and I really don't want it. I want to save passwords fast, so I'm going to use a guest browser. You can go incognito or do guest browsing, but when you're dealing with login forms, does anyone else have the LastPass plugin browser? Yeah, or something similar where it saves your passwords. It gets annoying for me. There are other ways of handling it, but for me, I just open a guest browser or something. Much easier. Localhost. Okay, jazz hands. So it's working. Cool. So for this site, I don't just want to come and see. I want to come to this site and I want to see something custom to myself, even if it just displays my name and some whatever. So in order to have that, we're going to have two steps. First, the user is going to have to log in, verify that they are who they say they are. And then we're going to have to give the user a cookie that the browser will hold on to. And every time the browser makes a request, if there is that cookie, if the user is logged in, we're just going to show them their information. If not, we're going to have to. Sound good? So, create a login form. So, why am I using? Okay, so label. Let's create username and password. I think that's enough. Text. What should the type be for password? Text. Why password? What does that do? Which makes it secure, right? Nothing can go wrong after that. And the action. I don't know. We're gonna make a post request to login. Wait. So app.post login. Correct. What are we gonna do at this? Set a cookie. I mean, eventually set a cookie. What's the first thing you do when you post a form, an Express app? Not the first thing. Probably want to save that information. How do we get the information? Yeah, so we get it from the body, but can I just like get it from the body, or do I have to pass it? Body pass. So I'm gonna have to install full body and body pass. How do I tell the app to use body pass? Something. Something. As that little URL encoded extension. So now I can start grabbing stuff from the body. So what do we have? We have a and we have a path. Now we're going to log the user in. We're going to assume that the user already exists in our system. They've already registered. So for this, we're going to need a database. Favorite database. One. Database come. SQL is a database. Mongo is a database. I'm going to use a JavaScript file because I don't want to. Good to know that you guys know database. So I'm just going to create this fake database, database.js, which kind of looks like a NoSQL database because let's give them an idea. Name. Password. And for fun, let's give it a flag. Admin. We're going to create a second user. Just a bit of extra information. You know, you might have a user, and some of them will be admin users. Admin users. Yeah. Right. What are you going to give them access to? For example, let's say we were creating user compass. Might have stuff like that. So I'm just simplifying it, creating an add flag. I don't know what this app does yet. We'll put that out later. We're going to create the second user as admin true. Don. Just remembered I told him he could watch through the camera, so he's watching. What's Don's password? Yes, his. Okay, he's probably not watching. Might be watching. Right. Can you use emojis for passwords? I don't know. We'll find out. Yeah. So necktie. Why not? Should we add any more information to? Well, maybe. Got like quirky facts, right? This could be. Quirky fact. I have a. Huh? All right. Going. Got a quirky fact for Don. I like ties. Is that quirky enough? But I like ties to be. That's fine. You can say whatever you want. He's not here. That's what he gets for not showing up. All right. Let's make something up. This might be true, or it might just be something that he'd like to be true. But I have a. He may have 300. Okay. So we got a database. We got some users, password, and when a user logs in, we just need to check if the username and password matches any. So first thing I'm going to do is bring in my database. What did I export? Where are my pair programmers? Export anything. Export. So then I'm going to users require users. The nice thing about keeping my database in a different file right now is that I can do all these tests. I can mock this, and then later on in my index.js, I can kind of just replace this base. You know, make a few changes here, but it's as if I'm using it. Okay, so when I have a username and password, I should check foreign. The key in if ID dot use and okay, good. Then the user's logged in. Brilliant. Or we'll log the user. They have the right credential. That's cool. Log. Else, what should we do if they give an incorrect user password? Yeah. Do we tell them which one's incorrect? Or should we just tell them correct? Why won't we tell them which one's as well? Yeah. So why is that bad? In case it's not actually them. If we have someone, a bad person that's trying to get into the site, and we tell them if the username or password is incorrect, then if we're specific and say the password is incorrect, then they're going to know the username is incorrect, and they can just keep guessing passwords. If we say that their something is incorrect, then they don't really know. They're going to have to keep guessing for a lot longer. They don't know what you are. So it's for security reasons. I'm just going to res or password is in yes. Sites were more like that. Sassy site. Okay, cool. And if the user is logged in, what are we going to do? Yeah. I mean, essentially, yeah, we want to be hello. But we need that to be able to persist longer than just this request. So what I want to do is I want to redirect them back to the home page, and every time they go to the home page, it's hey, hey Sam, here's your quirky fact. So if I res root, then that's half of what I want to do, and the rest, yeah. At this point, if I redirect all the data, and if the user refreshes the browser, again, the browser's not going to know who the user is. So this is where we need cookies to start making sure that every time the request happens, we know. So we want to essentially package up this user data. We have a user password quirky fact, and we're going to hand it off to the browser. And the browser is going to hold of it, and every time it makes a request back to us. That way, when it makes the request to the directory, we can say, hey, do you have all that data that we gave you? And if they say no, it's like, well, you probably weren't logged in then. And if they say yes, well, we have all that data. So let's use a cookie. How do I use a cookie? Library do I? Parser. Body parser and cookie. Okay. And how do I use cookie parser? Anyone that come? Let's take a look at cookie parser. Okay. So parse cookie header, populate request.cookies with an object keyed by the cookie's name option. We're using cookie parser. Okay, we already are. Require it and just. And then there's some more documentation on certain things. The main thing here is that every request that comes in our Express app now is going to have this cookies property that's going to contain every cookie for the site. And if we use res.cookie, save cookie to the browser. So send the cookie to the browser's going to send it back with every request in this request doc. So before we redirect, I'm going to say res.cookie, and this accepts a key value pen. Look at that, good documentation. Set the cookie name val with given option. But it takes a key value pair. So the key I'm just going to say is of the app, and the value, the current user, current ID. Oh, there's something very wrong with this. No, it's going to keep going through the for loop forever. There were 1,000 users. That's pretty good. Let's refactor. So I'm going to say let find. So if it finds a user, we're just going to say user, current user. And then how do we stop a for loop from executing? What's the difference between break and return? Break will break out of the for loop and continue executing the code till the function. Return will stop immediately and the function is. So we're just going to break out of the for loop and then we're going to continue our code down. Okay, so we're going to loop through all the users. If we find the user, we'll save the user. So that's cool. If there's a user. If there's a user, okay, then we will log the user in, and else we'll. So right here is where we're going to say response dot cookie user key value pair to, and then I'm just going to direct through. Cool. Otherwise, we do that. Good. Okay. This will save the cookie to the browser. The next thing, well, actually, should we see this in action? Let's see what exactly. So nothing has changed with the get root rendering the index. That's exactly the same. But now when we log in, if there is a user, we're gonna run this line of code. We're gonna save a cookie to the browser, or at least we hope it's gonna. So let's run this. Log message. Never gave it a what? Like, Gumbo? Which label? Oh, I didn't. You're right. That shouldn't make a difference in that. Elements are just not showing. But yeah, that is a very good point. Put in user. Not in my index or my database now. Sometimes. Oh, there is a form. Apparently, there's a form on this. Hmm? Oh, I'm too zoomed in to see it. Where is this? Wait, isn't it? Wait, is that it? Uh, um, that is a form. How do I add a? Oh, I don't know what purple is. That's the post request though. Got get to root, which gives me the. I mean, my form is there. I just don't. Who can figure out what's wrong? I am at a loss. Might be off, but this was working. I think it was the stuff, and I'm zooming. All right, it must have been something to do with the margins. Anyway, here's the form we wanted over. Username and password. Okay, where were we? What were we looking at? We were going to see what happens when we now log in, now that we are setting up cookies. Okay, so here's the network tab. This is a great one for checking HTTP request data. So what I'm going to do, make sure everything works. Enter something correct. Okay, username and password is correct. Cool. Now let's enter something. Sam and Jazz hands. So Sam, Jazz. Okay, so nothing's changed because we're not handling the cookie on the other side. If we take a look at this log request, we'll see. Okay, we make requests. There it is. Request to post. Cool. We post request to login, sorry. And we take a look at the headers. The response, get this thing, set cookie. And when a response header comes back saying set cookie, create or update a cookie with the data we need. Here's the key for the cookie that we made. And here's the whole JSON object. It's URL encoded, that's what all are. What's percent? 20 is space. Not sure what percent 22. If I had to guess, I would say for a quote. Well, I think it's a quote actually. Probably a site that would tell. But this is the JSON. Here's user ID 1, and yeah, everything. And then every set cookie followed by this thing path. This is the root path, which means that this cookie should get sent to this site for every page. Sometimes you can say this cookie should only come back for the specific sites here, pages here, but this is going to be for the entire site. So now every time we make a request to localhost 88, our browser, it now owns this cookie. It now has this cookie. It's going to send it to the server with every request. It has all this data. So I can refresh the page, and it made a request to, and in the request header, cookie. So every time it makes a request now, it's got this cookie that has all the data in it. Which means that if we're making a request, data root, and we want to grab that cookie data, we now can. So we've got request.cookie user is the user. Maybe we'll just pass this into our index file. Want to understand what that's doing? No? This is the equivalent of that. I think so. Okay, that. Does that make sense? So this is grabbing the user from the cookie, user information, and then I'm making an object where the key is user and the value is that JSON. So this user object should now contain username, quirky facts. There's all that data. I'm going to pass this to my index file. And so in index.ejs, quick check. So if then we're going to show them some custom information. Something else, we'll show them the login form. Okay, so if we have a user, what should we do? Hello. Hello, user. User. What else? Print out that quirky fact. And let's just show. Okay, does that look good? Any questions about my EJS code there? Okay, so passing in the user, if there's a user. Anyone used a NodeMon? Now it's a little. So what do we expect to happen when I hit refresh? Idea, thinking, realizing. Hello, Sam. I have a keyboard shortcut for jazz hands, admin. No matter how many times I refresh this page, that is going to happen. And why is that? It's because if I head over to this application tab here and I click on down here, we can see that this cookie exists for this site. This user cookie, value, ID, that exists for this website, localhost 8080. Every time this browser makes a request now to that site, it's going to hand the browser this. And all the server has to do is, well, accept the cookie. Here's the cookie for you. Let's use it. Any questions about that? Okay, so if we inspect, go back to the network tab, if we inspect the cookie that is getting sent and returned and passed around a lot, we'll see that it has all of the user, everything, including my password. There it is. Password. Jazz hand. Is that okay? Is that okay to pass around a password? How would someone? Yeah. How would they get the cookie? Well, call it. Wait. But they wouldn't be able to get the cookie that's on my browser. Yeah, there's actually a ton of ways someone can. Inspecting internet traffic, there's a ton of ways. And yeah, if anyone got onto my laptop, there's my password. It's just a lot of extra information that's kind of unnecessary. So instead of storing absolutely everything on the browser, what else could? Well, we got the database. Yeah, here's all the information in the database, right? So we don't need to store the browser. We just need to store a way of getting that, like kind of an ID. ID. Let's try that. If we store just this user ID, there's no passwords, no sensitive. And can we still get the exact same? Do we lose? No, not really. We have to do an extra step. We have to request it from the database, but that's fine. So let's, instead of the whole user, I'm going to create a cookie ID. And I'm going to pass the. Then when we get it back. And then here's the extra step. I'm going to have to grab the user from the database with that user ID. One extra step. For added security. Go past the user. So pretty similar. Now I am just going to remove. Click on it, delete it. If you ever need to remove a cookie from a site, so I've now removed the cookie that exists. So if I refresh the page, it should send me back to the log. But now when we go through this process, ID should be the only thing that gets. Perfect. Network request. ID 1, path same. And when we make the request, cookie, user ID 1. Discover application, user ID 1. Yeah, works exactly as we want it to. Is there anything wrong with that? Is that okay to do? Or any security issues or anything? What information? But how would they get that? They wouldn't be able to call the database. Unless they had access to the database. But then that's a whole bigger security issue than cookies. Anything wrong with you? Yeah, so if I come in here and I modify a cookie, because that's fine, do that, any browser can. Now what's going to happen if I refresh this page? I'm going to be done, have a different quirky fact, and here's a big security issue. I'm now an admin. I don't know what our site does yet, but whatever it does, I now have a way of being admin by changing the. So kind of a flaw in cookies. Anyone think of a way around this? If there's a hash, that would help. What kind of hash? A random hash. Yeah. So when we start saving it as a hash, let's say we didn't do one. Let's say, I don't know, whatever. Then that would be a little bit more difficult to crack. But most hashing algorithms, well, does anyone know hashing? MD5, let's say MD5. You're gonna at some point be able to see a pattern with something like MD5 or SHA-1, and you're gonna be able to pretty much guess what the user IDs will be. You need to make it something really not guessable. It doesn't have a pattern. So hashing is an answer, but we have to be smart about the way we hash. We can't use something that's easily guessable. I mean, numbers 1 and 2 are very easily guessable, but something like MD5 would also be. So we need something a little bit better. So this is where we enter the subject of session. Anyone heard of a session? Sessions and cookies? Sessions. Yeah, that is a feature of both sessions and cookies. That when the browser or when the server hands this cookie or session to the browser, it sometimes comes with timestamp. This is valid for a day or 2 months or a year or whenever. These ones that I'm passing back are valid forever. And at those times, the browser should then get rid of that cookie. But it's not specific to session. Let's take a 10-minute break. When we come back, we'll look at how to solve this cookie issue by using session. Okay? Ooh, NodeMon. Why would I use NodeMon? Good question. Okay, so when I did node index.js, it started my server. Then I made a change to my code, and then I had to press Control-C and redo it. It keeps me from having to do that. Let's say I make a change to any one of my codes. I don't know, it could even be an extra enter, why not? And I hit save. Notice there's 3 green sections. If I hit save, there's now 4. It basically restarts, do changes, and starts up the server using. Exactly. It's nothing special, nothing magical. It's just out for change every time you hit restart. So it's kind of handy. Right. Yeah. I'm making a lot of changes right now. So yeah, super handy for development. npm install -g nodemon. Yeah, it's just a package, so you don't have to do -g, but most of the time, the nodemon, there's little reason. -g. Well, we had a whole thing that you were gonna do when you came in, and then you come in now. Yeah. Come in now. We weren't sure if you were watching on the camera or not. So I said, you know, there was like 50-50 chance. So we made up. We needed. I'll let you see. Yeah, we needed a password for Don, and we also needed a quirky fact for Don. And considering they're in week 2, they know a couple of facts about you, but not every fact. So so we went with that. We've looked at cookies and the flaws in cookies. When they get back, we're going to look at sessions. Yeah. I logged in as Don by changing a user ID. Yeah.
And on the shop in November, decided to apply in December.
Sorry. If I was Joe, come in. There's some Christmas. So, I mean, Joel, I mean, Don, sorry. To be a web lecturer, one must immerse themselves in web lecture. I guess Joel's the only web lecturer I know. Yes. Oh, Don, you said I was a bright guy. I mean, I don't know if that was to get me to stop playing a ukulele or if you actually mean like a thanks, Dad. Do you have any Christmas plans, Don? If I had to guess, I would have said that. Yeah. Anything I wouldn't guess? Cool. Anyone doing anything exciting for Christmas? No? No one's... Who's going to work on Lighthouse Labs work over Christmas? Excited for the week 5 stuff. Let's have a Christmas like this. Huh? Calling my Christmas that ugly? Yeah, it's an ugly. It actually had the tag ugly. Got it from, I can't remember the shop name. Still a bunch. I don't know, we should do like an ugly. Yeah? Everyone looks stoked about it. Especially Don. Alright. Like the same reaction I get when I start talking about like free time. Yeah, what are you doing on Thursday night? Oh, boot camp. I my favorites is having like a long day, walking to a room of boot camp students. Oh, you guys have no idea how hard work is, right? Is that everyone back? Close enough? Alright. What did I say we were going to talk about when we came back? Sessions. Anyone Google sessions? Right? Tell me what a session is. So, a session. Let's at. We're going to use something called cookie session. We're going to Google that and let it tell us. Okay, so sessions. You guys don't have to read it anyway. A user session can be stored in main ways with cookies on the server or on the client. Now we're going to be using a module called cookie session, which stores the data client within a cookie. You can store data with Express session, which will store the data on a server or a database. So how a session works is that a session will save a key in a cookie instead of the user ID or some other bit of data. Save a key, and it will use that key, or we can use that key to then grab the data either from a cookie in this case, or we can save in a database. But for this, we are going to be saving all the data in a cookie, just as we were before. But what session is going to do is going to encrypt that data. So it's not going to look like a user. And it's not going to be guessable like an MD5 hash. Cookie session is going to take care of all of that encryption and hashing. And we can just use this Express session module to store data and get it back. And we'll see how this works. So first thing I need to do is, instead of using this cookie parser module, we're going to need to use cookie session. npm inst cookie session, and parser, let's use. And how do I use cookie? Copy and paste something, copy and paste. Cookie session. We're not going to worry about the age. So, cookie session accepts two parameters. The name of the cookie, we're going to call that session, or we call it anything I want. Can I have a better name? Last time we called our cookie user. And then we need a secret. What is a got a secret? Oh, sorry. A secret key is a string that the session is going to use to help encrypt our data. So any of the visible data that's on the browser in the cookie will be seen by anyone, and can be altered or whatever. In order to decrypt that, in order to get the data out of that encryption, it's going to need to run a decrypting algorithm with this bit of text that we have on the server. So unless you have this key that we're going to keep on the server, you won't be able to decrypt the information. Makes it secure. But if I commit this code to GitHub, then everyone can kind of see this string. So if I put some top secret key in here as plain text, people may end up finding it. So what should I use instead of just plain text? How can I keep data more secure? Key. Reference to another file. Any file in particular? Have you guys used this yet? Nope. So this is an environment variable, a variable that will exist on the server. So if we set this variable on the server itself, not in our code, but actually on the Node will be able to grab that from the server and just use it. It only exists there. It doesn't exist or any of that. If it can't find this key, then it will use some secret key for development. Of course, we could keep a file on that server and use that. Whatever. As long as it's not within here. But yeah, this is a very common way of doing it. So we now have this secret key. We're telling Express to use this cookie session middleware. Now we just need to update our code. So instead of request cookies, it's going to be user. I do need my. Oh, you know what? Maybe I don't need them. Let's see how we use them. Request.session. Cool. Oh yeah, it's actually more simple than you. I don't know if this is a good thing or a bad thing. I'll let you decide. But with the cookies, notice that we use res.cookie set the cookie, and then request.cookies to get the cookie. Res.cookie request to get the cookie. With session, with this cookie session library, it's actually request. Yep, request.session both times for whatever reason. And instead of using this kind of square bracket quote syntax, everything's just dot syntax. So request.session.userid will now give us that. And there it is. Request session equal to. So not too much of a change there. We just changed changing from using cookies to sessions. Okay, still storing the same bit of data. But if we head over to the browser and clear any current cookies, refresh the page, let's see what happens now when we log in. Okay, same result that we wanted from before. The server is still giving us this custom experience, all this information. So as far as the user is concerned, the normal user, same thing's happening. But as far as the hacker is concerned, well, now I have these two things. If we look at the network request as well, we have these cookies. Instead of having a user ID cookie, we now have that cookie session and session sig. And these are just encrypted values that I don't know what I'm doing. Plus there's two values. I don't know what to do with that. Like, this would be much, much more difficult to crack. How do I now log in as Don? I don't know. Got any guesses? Don? I don't know. I could try modifying these, but it's probably not going to work. So sessions just took care of encrypting our data for us in this case. And it's doing a pretty decent job. And this is definitely a better way of storing data through a cookie. The other way, we were storing bits of data that could be used by someone malicious to get into our site. This way, they can't really do it. I mean, we wouldn't, because every session, or we can't differentiate between that I know of. You probably wouldn't want to use ID, but we could, I don't know, name this to Christmas sweater. This won't rename the current session. What this will do is create brand new session with the. Oh. So if I'm in Chrome and I rename these, am I like renaming the name? Yeah. So we're still checking the user ID, but these two bits of data together are somehow the user. So we're still getting the user ID. It's that before it gets to the browser, it's encrypted, and before we use it on the server side, we decrypt it. Well, we don't. We let cookie session. So renaming stuff here, yeah, like we can rename stuff, but it's not gonna really do us any. Like this is keeping me logged in Christmas sweater. If I rename this, or we do refresh the page, lost data. So yeah. Any questions about sessions? So what's the benefit of a session over a cookie? Plain old cookie. Yeah, safer. It's much more difficult to crack. We're still using cookies. Like, this is a cookie, cookies, to store the data on the browser. That's how the browser holds the information. It's just through this process of encryption, it's a session. Cool. That now works pretty well. That's pretty safe. We've got users that can log in, and users that can log in. And when they logged in, we can persist them. They can refresh the page as many times as they want, and we can give them custom information. On top of that, we have some security protocols in Measure to make sure that I can't, for instance, log in as Don or do something that I'm not supposed to. So this app seems pretty safe. Yeah, for now. Is there anything anyone can see or anyone seen so far that's still not quite safe about it? This one might be. So if I again log in, it does appear to be the same. Is that the case? Yeah. Okay. Like that. It'll be very difficult to crack, but I'm guessing you solve that like in the array of keys. Yeah. Okay, so here I'm providing one key, but this is an array. So if I want it to be more secure, because you have pointed out something there, I can use more than one key. It will cycle through these keys. So each time it will use potentially a different key, meaning that the same exact, in this case it's a user ID. So let's say we had two users with some sort of pattern. It would be a pattern that you couldn't really get because, like, yeah, changing all the time. Yeah. That's one way, yeah, to improve the security. So we take a look at my database. Is there anything that's not quite secure, not quite right here? Just read the password. John, you can take a look at the quirky fact and password. This is what students know about you. I wasn't sure if this one was true, but I thought it's probably like you at least want it to be. Okay. Yeah. Close enough. Okay. So you, on your way, on his way. You're almost right. Right, the passwords are in plain text. I really shouldn't be able to read this necktie emoji in plain text or jazz hands plain text, but why shouldn't I be able to? Why? I mean, it seems bad, but why is it bad? Why is it bad to have plain text passwords? Well, I mean, who can see the database? Only authorized people, right? They could use it. So people that are authorized could see passwords. People that are unauthorized see stuff in the database. They hack their way in. Yeah, they probably could. What is a database? Yeah, storing information on a computer, on like a computer that exists somewhere in the world, right? So if I went to that place where the computer was that is my database and picked up that computer and took it home and plugged it in and looked at the data, there's many ways. Some are more realistic than others. But yeah, if someone gets into the database, they can see passwords. Think websites store passwords like this? Hopefully not, but yeah, some do, and that is awful. Yeah, just you use one password, then I mean one of the main down or flaws with that is that a lot of people like who uses the same password for multiple. All right, so remember those people, find out their password, hack them. So many reasons why you shouldn't do that. I suggest LastPass or 1Password or anything, just as a security tip. But yeah, if I find your password and username for this, I could probably guess that you're using that exact combination for a couple of different things. There are big sites that do this. I think there was a scandal with Reddit recently. I don't think they were storing plain text passwords, but they were not hashing them. 2009. That's like way too recent. PlayStation. Do they have plain text passwords? Yeah. Bad stuff. It's horrible. It's done. It's horrible. You guys will not do it. You will not have Lighthouse graduates coming out of here and storing passwords in plain text. It's awful. But then what do we do with passwords? Not store them as plain text. Encrypt them. So we've talked a little bit about encryption and hashing. Are they the same thing? Are they different? Anyone tell me anything about either? What's encryption? Will be something else. So both encryption and hashing involve taking something like jazz hands file for okay, taking something like jazz hands and making it seem like this, but really it's still jazz hands. In the case of encryption, I can go from jazz hands to whatever this is, and then I can also go back to jazz hands. There is a way of encrypting it, and there is a way of decrypting it. Okay, so the data is not lost. Jazz hands is never lost. We're just making it look like something else, and we can get that data back later. But with hashing, can we get the data back? Good guess. No, we cannot. With hashing, you will do some sort of stuff that is gobbledygook, random. You make it come out the other end looking like that, and there is no way of getting back to jazz. That data is lost. It does not persist that bit of data. It just makes it look like something. Which one do you think is safer to use password? This one. Which one? Raise your hand for encryption. Raise your hand for hashing. Everyone look into the back of the room. Why is hashing safer? Yeah, so once it is hashed, once it's in the database, in this case, the passwords are in the database, there is absolutely no way of getting that data back. You've got this, but can you figure out what my password is? No. Got that though. Like, so we can probably verify that you're the person you say you are. Just we can in this case, but we can't get that data back, and that's a very important thing, a very important difference between encrypting and when we're dealing with passwords, we always want to hash them, store the hash in the database, and there's no way of getting back to that original data. It also means that if you wanted to email someone their password, there's no possible way of doing that. Someone can't go to your site, I forgot my password, and you like quickly dehash and that's just not a thing. So if you ever go to a website and they email you your plain text password, just change it, probably stop using this, but if you have to use this password, it's completely different to what you're using for anything else. They are not as secure. Okay, so we're going to use hashing. Does anyone know any options for hashing? Any libraries? Any algorithm hashing out? math random, would create a random number. We wouldn't hash a string into something else. We need to take a string. We need to. Someone said something earlier. MD5. Why wouldn't we use MD5? 5's hash. Hash. No, MD5 is hashing. Let's double check there. Why wouldn't we use MD5? It's not a very secure hash, and it's been figured out by a lot of people. There are these things on the internet called rainbow, and they are just millions of passwords that have been hashed using. And all you have to do is take, go through that table and check if they exist. And I guess, all right, password 1 hashed to this. Try it. It's not a super secure one, and people figured out how to get around it. Any other hashing out? The great thing is, MD5 was once very good and used probably the preferred way of doing things, but as time progresses, you'll find these certain security measures, these certain things that we use become less secure, unsecure, not insecure. So as web developers dealing with this kind of stuff, we have to stay up with the most modern, and it's good to know which were popular but are outdated now and not secure anymore. MD5 is one. If you ever heard of SHA-1, that is also one that is outdated and secure. The current, I believe it's the standard for everyone, is this thing called bcrypt, which is much more secure for a couple of reasons, and we'll look at those now. So first of all, how do I use bcrypt in my Node app? Well, I can npm and bcrypt, and they have a password. In this case, and I want to hash it using bcrypt. I can just hash crypt, and it's going to accept my password, and it's going to accept a number. When I console log this hashed, we can expect something that looks a little bit different. Oh, it's not a function, right? I should have read the docs. Never done that, just get. Hash sync, look good. Decrypt dot hash sync stand. Think you want? Synchronous. Okay, so here's my hashed thing. Here's my hashed jazz hand. To run it again, here's hashed jazz hand again. Notice it's a different hash. Great benefits of decrypt. Again, it's a different hash. Come back to that. So how did I do that? Well, I called bcrypt hash sync, put in the password, put in a number. Hash sync, there's two methods here. One called hash, which is asynchronous, and one called hash sync, which is synchronous. Want to know more about that? The bcrypt documentation has here we go. Why async mode is recommended? Sync mode, async, yeah. And if you have any questions about async code versus synchronous code, that is a question for take up some of the time with that. But yeah, we're using this hashing function that will hash the password, and then there's this number. And this number is known as the salt round. Again, there's some good documentation here. A note on round. Basically, what the salt rounds, the number in there, it will take that number, it will take 2 to the power of that number, so in this case 2 to the power of 10, and it will hash the password in this case that many times. So it will take password, hash it, take that hash value, hash it again, take the hash value, hash it again. Power of the rounds. What is that? What's 2 to the power of 1? Who's 2 to the power of 2? 3. 4. 5. 7. 8. What's significant about 2 to the power of 8? Comp sci. John, you're gonna out of your chair. The number of different values you can put in a 1 byte. Okay, so yeah, comp sci is going 2 to the power of 9 is 256. Close enough. 500 and something. 2 to the power of 10. What's 512 times 10, 20? Numbers should all be pretty familiar. So every time we up the number, we are doubling the amount of times it has to hash. So it's not like it's hashing it 10 times. No, we put in a 10, it's now hashing it 1024 times. If I put in 11, it's 1,000 or something. Put in 12, it's going to keep going up and up. Now, why is that significant? What's significant about that? Think about it for a second. If I put in higher numbers, let's say we put in 14. Run this again. There was a bit of a delay there. Whatever, we'll go. Significant. A really high number. What will 20 do? What time do we have till the end? I got like 37 minutes. Got any good jokes? Nicely. To you and I, it will look like this still. It will hash it. It just will be very, very quick. And it's still going. Nicely, they did this table here. So we did what? We did 20. So they don't have the number 20 there, but 15 is about 3 seconds. 25 is about an hour. We went up to 31, 2 to 3 days on a 2 gigahertz core. Yeah, so this could take a while. I don't know how long 20 is going to figure that out. But yeah, how might we use it to our benefits? Ideas how we can make things more secure. The fact that it's delaying. I want you to think for a second. Let's say I was a brute force hacker and I just had a list of literally every word that ever exists, or every combination of every letter and number. And I just put it in like a for loop or something. I just keep hitting the network, hitting the API, and trying to log in with all those passwords. What might be a benefit if the server kind of took maybe a second to hash it? Even half. It would take significantly longer for people to try to hack in. If everything's running in milliseconds, that loop's going to execute really quick. But if every single one of them takes, well, if I have 1 billion passwords, if I have more than if I have 1,000 passwords, 1,000 seconds, that's still. So it slows down any brute force attack, while also making our password incredibly more I don't know, more secure. John had a good word earlier, but I've forgotten. So it doesn't, like to you and I, it doesn't really look any different. But this is significantly difficult to crack than this one, 10. Power 10 encryption. So we win twice here. We get more secure password, and it takes slightly longer, which makes it more difficult. Now we don't want to take it too. We don't want users to be waiting 3 hours or an hour to log in. So we should pick a number. I think 10 is usually. I've heard people say 10 is a bit low, so probably around like 11. Preference. 11, yeah, around that number is good. You don't want to go too low. You don't want to go too high. If I do 11 and that was quick enough for a good user experience, slow enough to stop any hackers, force hackers. And there's another cool thing about bcrypt. So I mean, as if it wasn't cool already, right? Hashing so many times, taking enough time that hackers can't. Every single hash is different. So maybe you think, oh yeah, this definitely is jazz hands, but oh wait a minute, on like how does it do? The cool thing about bcrypt is that for every hash, it creates this random salt, likes its hash salt. So it creates this random value, completely random every time, and it uses that value to hash your password. And it stores this data within the hash at the end. So, I mean, you can kind of decrypt this. 2 is the version of bcrypt that I'm using. 11 is the I said. Some of this data, the hash, not the hash, the salt, and the rest of it, password, but hashed, completely unreadable. But to anyone, like that's just you can't do anything unless you. Well, I mean, all you can do is check if a password could be hashed to that value. That's all you can do. And how long is that going to take? Well, 2 to the power 11 bcrypt, whatever cycles. So it has all this information here, but you can't really do anything with it. Secure bit of data. So because 2 hashes aren't going to hash to the, or 2 strings, whatever, aren't going to hash to the same value, we can't just say, okay, if let's hash this and hash the password and see if it's equal. We have to actually use script.compare. Hashed. Yeah, give it the hashed value and the unhashed value. And it's going to use all of that data in the hash, salt, the 11, the 2, whatever, and it's going to see if that value would hash in the same way currently stored one in the database. So if we do course, because I have to do sync. Cool. Nope, not that wrong. See how compare sync. Plain text password, the hashed password. Got it the wrong round. That's invalid. Bugging that. Okay, so plain text password followed by the hash one. Let's compare sync. Okay, true. So it can hash it, and then it takes an equal amount of time to check the hash. If higher number hash come out, password or true or false come out later. If put in something else, password maybe, this is going to come out. That's how we compare the password. And what this looks like in database, take this, replace jazz hands with this string. Every password will now end up looking like this in the database. I wonder if bcrypt can hash emoji. Will explode? What? No. Do you think it works though? All right, if this comes out as true, at the bottom I'm changing my password to Jazz Hands. Oh, that's so good. Okay, so this was a tie emoji, but now it's this long thing that is. And I won't actually change the password to Jazz Hands. God, that makes me so happy. That makes me so happy. Okay, bcrypt supports Unicode. Okay, yeah. So my database is now looking pretty decent. I have the data that can be readable, and the data that should not be readable in any way, not readable in any way. Now, let's use bcrypt in the app. Via this, it's starting to get a bit messy. And instead of now checking if the user ID.password equals password, I'm going to plain text password that was sent up from the browser, hashed password. Get that right? Cool. So I'm just going to delete these cookies. Over. That'd be a difficult one, wouldn't it? Trying to make sure you got an emoji right. Circle. All right. So when I type in Jazz Hands correctly, again, the same result. As far as the user of the site is concerned, the experience hasn't changed. The same app to them. But we now have secure sessions that are difficult to crack, and if anyone can hack into our database, well, good luck figuring out what those are. I mean, sure, they have my quirky fact, and they know that Don has a different type every day of the year, but they don't know my password, and that's the. Okay, any questions about that password encryption? Yeah, no, because you need the credit card number, and you can't get that back. So there are some times when you need to encrypt, and other times when you don't need to preserve the data in any way, you just need to hash it, and that's secure. If you're dealing with sensitive data, it is kind of nice to use other people's solutions. For example, if I had a login screen, I could use Facebook login, and if I wanted to use credit cards, I could use something like Stripe. Then I wouldn't have to deal with this at all. But when you do have to start handling sensitive data, you're going to have to start figuring out first you're going to hash it or encrypt it, and then you're going to have to take care of that in the best possible. Bcrypt is what we're using right now. It is good, but in a year from now, it might not be good anymore. I have to use something else. You could stay on top of these things. As soon as Quantum comes out, Bcrypt's going to be lost because you process all those hashes like to the power of 100. So they'll need to figure out a new way, a Quantum way. That'll be fun. But yeah, figuring out the newest way to do this. I mean, you could, but as soon as you hash something, you can't get the value back. So it's kind of unnecessary. Plus, bcrypt takes care of so much like hashing and hashing again and creating that salt value that makes. So you don't really need to add anything more. Like. Yeah. Try. If yeah, so you could, but every time, in this case, using bcrypt. So really, the only way when your site is using for someone to try and hack in is to just start guessing. That's really the only thing they can do at this point. But when we do that, every time they that plain table of all of them, Well, this we've set to 2 to the power of 12 times, which is 2 to 3 hashes a second. So they could guess 2 to 3 passwords a second, which is not fast. They're going to be stuck there for a while going through the checking. That's no, because the compare, there's no decryption. The compare will just take some values, take this data, where is it? In my database. The version of bcrypt, the number of times it's the salt cycle, and I think thing, and it will just perform that hashing algorithm, plain text thing, and then compare them. The creators of bcrypt could create a faulty compare function that just put in jazz hands, but there's no way for them to get the password. Once it's hashed, it's hashed. Good analogy for fried eggs. Once it's fried, it's fried. You can't get that back to a normal. You can compare to fried. That's not a great analogy. It is like the data is locked. Once you've hashed it, you can't get that data. Yeah, exactly. So like something like this is the part, and everything else is data on how to hash it, which is fine. Anyone can know that because they can't do anything valuable with it. So this data will say, okay, take this word and use this data to hash it, and it'll take almost a second. Once it's hashed, do the end values, and that's really all it's doing. So, I mean, it's doing it in a great way, but that's it. No, can't decrypt after. It's just hash this thing in the same way we hash this thing. Are they the same? Yeah. Like I said, would mean that if you could run a billion comparisons a second, then there'd be an issue because you can't. All right, we're kind of at the end, so I'm just going to show you one more thing that's going to be somewhat helpful um, with your app today. Right now in my user database, I have a little bit too much information than what we just the user. This quirky fact stuff could probably be its own database, its own table, its own object. So what I'm going to do is facts. And I'm going to take these quirky facts out. And I'm going to stick them in. Each one of these ID, fact ID, have the fact. And then we're going to need to relate this. So, runs quirky fact user ID 2. Okay, separating the data up. Facts. Okay. So I've now separated the data up a little bit. Got my users table, object, and my facts object. And again, the experience for the user is not going to change. But when we're grabbing the user from the user, we can also grab the facts for that. So I'm just going to loop through ID facts, and if fact ID, not fact ID, yeah, user ID. So if the current fact has a user ID that's equal current user ID, perfect. Let's add that fact. Else will do nothing. So a bit simple. I'm just going to add it to the. Okay. Then I don't have to change my EJS file. But I could send that in as a separate fact. So they're two separate tables, and then I link them up by grabbing fact with the user. And that's the user. But the way the data is now different. Now have these two separate pieces. Quirky facts, existing facts, and the you may find that later today you might have users in your app that have things that they and they're going to be in a separate table. And you need okay, does anyone have any questions about any of that we've been over today? Cookies, session, script. Huh? Cool, then that's all I got for you. And the browser. Library. I wondered that. But I don't know. That's all good. We went straight. I think. Okay.